So that was the confidence interval part there. Let's do, so this is diff confidence interval. We can use the hypothesis test for a mean sheet here to come up with the hypothesis test information. So I'm just going to make a copy of that. Duplicate. Let's change the name. Diff hypothesis test. Did I name that one right? Yeah, confidence interval. And the only thing I really need to put in here is my data so I can get the right numbers there. So let's just steal those. I guess we need a new column first. Okay, so then instead of having these be given, we're just going to calculate them based on the data. So n is the count. Highlighting all that's not going to mess this up. I don't think so. And then let's get rid of the highlights. Average is the mean. Mean is the average, other way around. Data and std.s. std.s. Data. And our spreadsheet from before is now set to figure stuff out for us. It's going to find the standard error. It's going to find the t-score. Whoa, how can you have a t-score of -151? That was because I didn't change my hypotheses here. This ain't human body temperature, age difference. What should our null hypothesis be here? Well, the idea back from this data is that let's assume that there isn't a difference between the husband and the wife's age, that they're about the same. Sometimes they're more, sometimes they're less. So this should be 0. And looking at the data initially, this histogram I had, where'd my histogram go? I would hypothesize that the husband is older on average. So that means I'm going to go for a right tail test here. And yep, that's set up to do a right tail test. Mu is greater. And then there's my t-score. Remember, the t-dis does a left tail by default. So I could do a 1-, but remember earlier I saw there was a t-dis right tail option. So I'm going to try that. And it says, what's your x? That would be your t-score and your degrees of freedom. And I'd recommend, since the sample size is on your spreadsheet, click on that and then do a -1 so you don't make a mistake there. All right, so I'm getting a p-value of 0.02 of about 2%. So these numbers don't need as many decimals as they have. 2 decimal places is sufficient. Usually for the standard error, I usually do at least 4. Same for the t and the p. Sometimes I go to 5 decimal places. I'll just go to 4 today. Okay, so, or 5. So we get a p-value of about 2%. So at the 5% significance level, we would reject the null based on this one. And rejecting the null means we have evidence of the alternative. The husband seems to be older on average. Is another sample of 50 husbands and wives guaranteed to give me the same results? The answer is no. If the null is true that there really is no difference, then 5 out of 100 samples will give me a similar result to this one, which is a false positive test result, a type 1 error. Okay, so you never know what can happen. This could be a mistake, but based on my sample, the husband seems to be older on average. All right, I hope this was useful. You should make a copy of this spreadsheet at this point if you haven't already. So you can, under File in Google, make your own copy of it. And then you can reuse these by either plugging in numbers or plugging in data from your homework I'd also back it up with double checking with some stat key graphs to see if you're on the right page. And remember, whenever I do these problems, I usually do my by hand sketch to kind of check it out too. So write good notes. All right, that's it for now.